This section of the work is still trigonometry, but it's the trigonometrical equations that we're going to have to solve. Now, this is probably, or is among the toughest of the sections. It is a challenging section. There are some recipes, however, that we're going to develop in answering these problems. So let's just start off with a simple trig equation where they say sine x, okay, is equal to 0.5. So, whoops, I'm on the green pen. I want to just go to the black pen. Let me put a heading here. Trig equations. Yep. Trigonometrical equations. That looks like a W. I'll be the first to admit that I've just used an eraser to try and write. Trig equations. Let us say we've got sine x equals 0.5. Okay. Well, previously we said, all right, let us take the sine must go to the other side. How do I do that? I take the opposite function. I'm going to put it in red. And I said arc sine of 0.5. Go back and put in black here of the sine of x, right? The arc sine of the sine cancels it out, okay? Let's think of it like that, but that's not what's happening. It leaves us with x equal to arc sine of 0.5, and then I press on my calculator, shift sine 0.5, and I come up with 30 degrees. Cool, tick, I've answered it. Because if I put sine 30, I get 0.5. Okay, but just hold on a second. Just a sec. This is the sine graph, right? Okay, so there's 30 degrees. But just a second. There's 150 degrees over there. Can you see that if do you know what? Excuse me, I'm just going to make it a little bit bigger. Okay? I want to just sort of emphasize it a little better, perhaps. All right? Okay, like that. Now, you can see that if I put in, remember, this went up to 1 and this went to 0.5. But look, there was my 30 degrees. But there's another answer over there. All right? That's also going to be 0.5. And if I go backwards, okay, on this side of the graph, I'm going to get another 2 answers way down there. So what we're saying is that there's going to be a multitude of answers. It's not only one answer, there can be more. So we're going to have to solve for these, all right? Let's just have a look and say, hold on then. Let's put in sine of x equal to 150 degrees. Let me just rephrase that. Okay. Let's say x equals 150 degrees. Sine of 150 degrees is equal to a half. Let x equal minus 210. Sine of minus 210 degrees is, put in a calculator, a half. Okay. So, and we can go on minus 330. Sine of minus 330 degrees is equal to a half. Okay. So, there's 4 solutions, right? Why? Because the graph repeats itself. Okay. It is doing this, isn't it? Okay. It's doing this over here. And behind the scenes, it's doing that, right? Okay, so at the 0.5 there, I've got 2 solutions there and there, but I've also got 2 solutions there and there, haven't I? You can see that for sine and cosine, okay, therefore, for sine and cosine, we get multiple solutions. Okay, multiple solutions. Now, remember the domain business. Okay, the domain in this case is minus 360 degrees, okay, less than or equal to x less than or equal to 360. In other words, they have told us the domain is going to be from there to there, so it's going to give me 4 solutions. Just bear in mind that they can restrict the domain. So when you look at one of these problems, look at domain. Okay? No, you don't have to solve it the whole lot. They might just say, as an example, and which they very often say, for x less than 360 greater than or equal to 0, which means you're going to get 2 solutions. Correct? 2 solutions will come out of that. So always check the domain. NB. Look at the domain when you're doing one. Teach yourself now to get a handle on that domain. Let us look at a tan graph, for example. Tan. I'll do an example. We'll do an example for tangent. I'll just leave it for a bit. Okay? But let's just draw the tan. Oops, that's not what I wanted to do. I wanted to do this. Put it back to my original. And if I draw a tan graph, I get a graph that does this, don't we? Okay. At 90 degrees, minus 90 degrees. And then at 270 and at minus 270 degrees, right? We get the repeat of the graph. And over here, we get it coming up, and we get it coming up there. We get this graph repeating like that. So once again, if I had a y value over there, I am going to get, okay, equally 4 solutions. Okay. All I want to illustrate is that from the graph, if you put it in, you will get 4. Ditto, if I put in a negative, I get 4 solutions again, don't I? Okay. So for any value of here, I can get 4 as long as my domain is minus 360 to plus 360. So we always look at the domain and see if it has been restricted. Okay, that is critical. What are we going to get? Okay, so what they're saying is they want a general solution. Find the general solution. What does that mean? Okay, find the general solution. Essentially, they are asking us, find one that gives us any or every angle that we can possibly have that will solve the equation. Now we're going to introduce something. Introduce 360k and 180k. Right. What do I mean? K is an element of Z. Z are integers. K, simply enough, is number of revolutions. So therefore, K can be minus 4, minus 3, minus 2, minus 1, 0, 1, 2, etc., etc., and keeps on going either way. K is the number of revolutions, but it can be a minus revolution or a positive revolution, okay? And no puns required, please. Thank you on the word revolution. But what have we got? We have got a number of revolutions, okay? Yes, it's kind of superfluous in a way, but this is what we've got to get through, all right? Because the general solutions to these equations, it means that we can have, well, what? Let's just take an example, all right? Take a simple example of 30 degrees. Let's say that was a solution. 30 degrees is a solution. Okay, therefore, if 30 is a solution, okay, well, hang on. 390 is a solution, isn't it? Okay, and, right? And also minus 330 degrees, also a solution, right? So, and, k times that. So this K360, K180, the K360, okay, the K, so for sine theta and cos theta, we use 360 degrees, that's times K. For tan theta, we use 180 times K. K, oops, that was my bad, very much so. Thought I was on the thingy, and I'm not. K, element of Z. Right? K an element. So for tan, it's 1. Why? Because this is the period. This is the period. Right? In other words, we're just adding revolutions when it's going to repeat itself. That's all. Okay? There's a recipe coming for this lot. Okay? The next thing we're going to introduce is something called a reference angle, which is R dot A. Okay? And I'm going to show you how to use it. Okay? The reference angle, in essence, is going to be a basic angle from which we're going to work. Okay? Let's just have a squiz. Let us say, okay, there we go. And let me just, okay, I've got my reference angle. Let's not waste electronic paper. Reference angle. Let us just go back to sine theta equals x. Okay, x is a number. Okay, this is a, no, let me not call it a number because it can be a function as well. Sine theta is that. So step one, okay, is you write down reference angle is equal to arcsine of x. Okay, that is step one. Then step two, okay, if it's a sine, I'm just going to say step two, decide type. Decide type. Is it sine, cosine, or tan? Okay. Step three. Apply general solution for type. Okay. Right, now what are the general solutions for the type? Here they are. Okay. Please write these things down. You know, it really is worth it. Okay, because you won't remember them. Okay, so we first of all now general solutions for type. Okay, we can have an equation which is a sine type, which tells us, therefore, if it's sine theta equals x, therefore, we say theta is going to be equal to reference angle plus 360k, and theta equals 180 degrees minus the reference angle plus 360k. All right? That's if it's a sine type. Now you have to know these. You can't not know them. All right? The sine type is if it's a cosine type equation. This is the type of equation. Cosine type, we say theta is equal to RA, okay, plus or minus RA, plus 360 degrees K, right? And don't worry, I'm just write these down. And then if it's tangent type, okay, we say theta is equal to RA plus 180 degrees K. And in each and every one, you have to always write down K element of that, K element of that, and K an element of that. You always write it down just to show until we get to specific solutions, okay, where we're going to apply K. Now, if we say, all right, K is the revolutions, okay? We know that, okay? So let's do a few examples. Let's take a very straightforward one first, all right? And we go through the recipe steps. Just go through that with me, all right? Let's do a few examples, and here we go with one. Example. Determine the general solution of, okay, example 1, okay, all right, is sine theta is equal to 0.7660, okay. Let's go through the recipe slowly here. We say, first of all, step 1, I'm going to write it here. Step 1, apply opposite function to find reference angle RA. I write down RA equals arc sine of 0.7660. I put that in my calculator and I get 50 degrees. Okay? Right. Next step, step 2. Decide type. So I write type is a sine because that's what I'm being asked. Okay? It's a sine, therefore, okay? Okay. Therefore, we said apply, step 3. Whoa, look at my writing. I do wish I could write neatly. Decide type, apply, okay, the general formula for type, okay. So there we've got that now, correct? Apply the general formula for the type, right? Let's have a look. Here we go. No, there we don't. Apply. Okay, it's a sine type. And if it is sine, I say, okay, RA. So therefore, theta is equal to RA plus 360 degrees times K. And RA is equal to 180 degrees minus RA plus 360 degrees times K. Okay? That's the formula for the sine type, isn't it? It's this one. Okay? It's this one. It's a sine type. It's this guy here. All right? And there are the two formula that are going to give us the angles that we want. Okay, let's have a go. So I then can put in, and I say, right, therefore theta is going to be, leave it as blue, reference angle is 50 degrees, plus or minus 360K, and, and theta, silly me, look at what I did. Okay, trying to go too quickly, hey? And theta is equal to 180 minus 50 plus 360K. Therefore, theta is 50 plus 360K. And theta is 180 minus that is 130 plus 360K. $360K. And I write K is an element of integers underneath it. Right? So what it means is that 50 degrees will work, 130 will work, and I can add or subtract 360 from them to get the other angles that will work. All right? You can try them. In some of them, we are going to try them when we get to them. Okay? Right? Back to black pen. Example 2. Okay? 2, Kevin, 2. Write a 2. There we go, example 2. Cos x equals 0.3420. Right, what do? Step 1, I say reference angle equals arc cos, or cos to the minus 1 of 0.3420. That is step 1. That gives me an angle, in this case, of 70 degrees. Then I say decide type. Step 2, and I put type, cos type. Right? So it's a cos type. Cosine. Okay. Therefore, theta is equal to RA, and you say is going to be equal to plus minus RA plus 360 degrees K, which is going to be equal to plus or minus 70 degrees plus 360 K. Okay? Which gives us equals to what? And there are two. You could, I suppose, leave it like that. So theta is equal to plus 70 degrees plus 360 K, or theta is equal to minus 70 degrees plus 360 times K. Please remember, minus 70 degrees could also be written as plus, okay, 360 minus 70 is going to be equal to 290. Right, and put my degree signs, K, element of integers, right? So what you've got there is it could be, I'd leave it as the minus 70, okay? But it could also be 290. So don't panic if you look in the answer book. It's the same angle. How did I get it? Just recap. I went minus 70 degrees, is that right? And therefore the positive equivalent is 209. It's the same angle, right? Just measured negatively or positively. Here's another one. Example 3. Example 3. And example 3 says tan theta, same thing, find the general formula. Tan theta is equal to root 3 over 3. Step 1, RA equals arctan of root 3 over 3, which is going to be equal to 30 degrees, is it not? What do I do next? Next I say decide the type. So the type is tangent. Okay. Therefore, okay, theta is going to be equal to RA plus 180 degrees K. Therefore, I say that theta is going to be RA is 30 degrees plus 180 degrees K. All right. Remember, K can be 0, minus 1. Okay. So that's going to give me that answer like that. Okay. We're going to knock it up a gear in the next session. I can't start now because it's not a new topic as such, but it's slightly more advanced. Do you know what? I probably can do. I can do example 4. It's not too advanced, so let's continue. Okay, let's use the time wisely. 3 sine 2 theta. Okay, example. Okay, same thing, find the general solution. 3 sine of 2 theta equals 1.2. Now that's not in the right form because I need to isolate the trig function. Okay, isolate trig function, which is going to be sine of 2 theta is going to be equal to 1.2 divided by 3. Is that not so? Which is 0.4. Right? All I've done is I've divided both sides by 3 to get to there. Correct? Now I say, right, therefore, reference angle is inverse sine of 0.4, which is going to be 23.58 degrees. Okay, now you are going to find that these angles start to come in where they are not totally beautiful, okay, so or straightforward. So therefore, decide type. Okay, type. It's a sine. Therefore, theta is going to be equal to reference angle, okay, plus 360 degrees K, and theta is going to be equal to 180 minus reference angle plus 360 degrees K. Now here is the little trick. The reference angle was based upon theta, okay? But it's a 2 theta. So now we say what? You put the reference angle in because you say, but hold on, that's a theta. It's going to be, therefore, 2 theta is equal to 23.58 plus 360 degrees K. 2 theta is going to be 180 degrees minus 23.58 degrees plus 360 degrees K. Okay, it is going to be whatever, I'll show you now, okay, whatever is inside here, okay, whatever is after that function effectively is now the subject of the formula. So if that was 2 theta minus 15, then 2 theta minus 15 becomes the subject of the formula. I'm going to do another one straight after this with using that, just exactly that example. Go back to black. Therefore now I only want theta. So theta is therefore going to be, and you divide through by 2, correct? Let me just put it in green here. Divide, but I must divide everything by 2. Do you see that? Okay, let's just stay with it. And I divide by 2, and I must divide everything by 2. Guys, big error point there. Becomes 11.79 degrees plus 180K. Divide by 2. Theta is going to be equal to, that minus that comes to 156 divided by 278.21 degrees plus 100. How do you do it? Make sure you divide through by the 2. Okay? Very, very, very straightforward. Here's the last. I think this is the last one of these. No, there's a few more. All right. So what I want to do is we'll come back in the next one and we'll carry on with that, and we'll do some other forms of general solutions because we've got to factorize, etc. Please just remember the key points here, okay, is step 1, all right, is you take the opposite function, okay, or take the arc function, right, you apply that. That gives you the reference angle. Your whatever was in the brackets after the trig function becomes the subject of the formula and is equal to that specific type of solution. We're going to go through some more examples. I don't want to push it, otherwise I'll be way over time on this one. So please join me when we go through the next ones. This, as I've said before, is the more challenging side of trig. Okay, it is because we've got to develop the thinking and the recipes as we go. So far, we're getting a recipe for these equations, okay? And it works. You just follow it and you'll get your answers. Cheers. Have a great one. Bye.